All right, the title of these notes is going to be Function Operations. And this is going to be kind of the same thing we talked about in class yesterday, where when we were evaluating functions, the notation looked different at the beginning of the problem. But then when we were actually working it out, I was like, oh, I've done this before. I've plugged numbers in. I've gotten rid of parentheses. I've distributed things. I've FOILed things. So the same thing here. It's going to look strange in the beginning, but by the time you're in the middle of the problem, it'll be like, oh, this is old news. I've done it. So when we talk about operations, we're thinking like, please excuse my dear Aunt Sally, parentheses, exponents, adding, subtracting, multiplying, dividing. And so those are the four operations that we're going to address. So addition, subtraction, multiplication, and division. And the nice thing about the function operations is that they're kind of common sense. The way that you think that it works is the way that it works. So here, addition is going to be f of x plus g of x. You're just going to take the two functions. You're going to combine like terms, add them together. Subtraction is f of x minus g of x. You're just going to make sure that the negative is being distributed to the second function. For multiplication, f of x multiplied by g of x. This is going to involve FOILing. In fact, I'm going to actually write little notes here. So we're going to say distribute the negative. Distribute the negative here. We're going to say FOIL. It's a good thing to remember. And then division is going to be f of x divided by g of x, or they could write it as f of x over g of x. Okay. Now, the thing that gets students a little bit confused sometimes is that mathematicians couldn't just leave it like this. They liked to shorthand their notation. So they were like, oh my gosh, it's so inconvenient to write this many parentheses or to write the problem this way. So instead of saying f of x plus g of x, they would maybe shortcut it as f plus g of x. Or they might even shortcut it as f plus g. They might even just write it like that. So when you see something like this written, in your head you're going to go, oh, they actually meant to say f of x plus g of x. Eventually, when you've gone far enough in math, it makes sense to do that. You'll be like, yep, I'm right there along with them. I'm going to shortcut this. Sorry, that lighting is terrible. Shadow, there we go. But when you first get started, it definitely feels confusing. So they could write it that way. They could say something like f times g of x, or they could say f times g. What they really mean by that is f of x times g of x. They could write something like f plus g minus h of x. Or they could even write f plus g minus h. And what they really mean by that is f of x plus g of x minus h of x. That's what they actually mean. Like this, okay? So that's just something to keep in mind, that when they set up the original problem, they might be using the notation like this, where it's a little bit more straightforward. Or they might have done something to shortcut the notation out of laziness. And it's fine to do that. It's common for people to do that, common practice. And we'll just have to think of, okay, what do they actually mean before we do the problem? All right, so we're going to do some examples. I'm going to go ahead and just write down some functions here that we can work with as we do the examples. So f of x is negative x squared plus 5. G of x is 3x minus 1. H of x is x squared plus 2x. A of x is negative x plus 7. And z of x is 3x squared minus 2x plus 4. So we're going to go ahead and use those functions to do our example problems. For the first example, we're going to find f plus g of x. And so when I see this problem, I'm immediately going to say, okay, that's just funky notation that really means f of x plus g of x. That's all they're saying. And f of x is negative x squared plus 5. G of x is 3x minus 1. I put parentheses around them just to show this is one function, this is another function. Now, since this is a plus sign in between, I could distribute the plus sign, but it's not going to change anything anyway. So I don't really need parentheses around this group. The parentheses aren't doing anything other than showing, yep, that was the first function. There's nothing to distribute, so I'm going to go ahead and just write that down. And at this point, I can just combine like terms. So negative x squared and positive 3x, those are not like terms, so I'm not putting them together. 5 plus negative 1 is 4. So there's my answer. Pretty straightforward. You're just adding two different functions together. Again, you've done problems like this, but it probably started there. It was like, oh, add these two things together, and you were like, okay. Now the only difference is it's going to give them to you as the names of the functions instead of as the like expression written out. So that's all. Just the beginning step is a little different. The rest of it's the same. All right, for our next problem, we're going to say that we're doing h minus a of x. So that's really just funky notation that means h of x minus a of x. And h of x was x squared plus 2x. And a of x was negative x plus 7. So for the first set of parentheses, there's nothing to distribute. We can just kind of get them out of the parentheses. With the second set, we do have a negative to distribute. And the common mistake that I've seen students make, especially this year, especially these classes, is taking the negative and subtracting the first term, but not subtracting the second term. I see lots and lots and lots of students do that. So make sure when you do a subtraction problem that you're subtracting both terms. So x squared plus 3x minus 7 is our answer. All right, we can even do something like z plus g minus f of x. So this is z of x plus g of x minus f of x. So z was 3x squared minus 2x plus 4. G is 3x minus 1. F is negative x squared plus 5. So this parenthesis is good. Nothing needs to happen there. This one's positive, so again, I don't need to worry about distributing anything. It's just going to be exactly the same. But here, this is a subtraction problem, so I need to distribute that negative. So plus x squared minus 5. So I have 4x squared plus x minus 2. All right, let's go ahead and do a multiplication problem. Gonna do h multiplied by a of x. So what they mean by this is just h of x times a of x. H of x is x squared plus 2x. a of x is negative x plus 7. And anytime we do a multiplication problem, we just have to FOIL. Sorry about the lighting. X squared times negative x is negative x to the third. X squared times 7 is 7x squared. 2x times negative x is negative 2x squared. 2x times 7 is 14x. So that's negative x to the third plus 5x squared plus 14x. All right, and then the last example, this is so easy, it's difficult. Students will be confused by how it looks and think that they don't know how to do the problem, so they'll skip it, they won't even try. And then I'll show them the answer and they'll be like, oh, that was it? So this one is funky notation, but it just means h of x divided by z of x. And literally all you have to do is write h of x over z of x and you're done. So there's h of x. There's z of x. Finished. That's all you got to do.